We need to prove that secant theta raised to the power of 4 minus secant squared theta, that's equals to tangent theta raised to the power of 4 plus tangent squared theta. So we can start either from the left hand side or the right hand side. So let me start from the left hand side. So here we have secant theta raised to the power of 4 minus secant squared theta. Now from the two terms, if we take secant squared theta as the common factor, so the secant squared theta will then get multiplied to secant squared theta minus 1. Now we're going to use an identity. We know that sine squared theta plus cosine squared theta, so that's always equals to 1. What we'll do, we'll divide each terms by cosine squared theta. So we have sine squared theta divided by cosine squared theta plus cosine squared theta divided by cosine squared theta, and that will be equals to 1 over cosine squared theta. Now sine squared theta over cosine squared theta, that can be also expressed as sine theta over cosine theta whole squared. The cosine squared theta and cosine squared theta will get cancelled from the numerator and the denominator, leaving us with 1. And on the right hand side we have 1 over cosine of theta whole square. So the ratio sine over cosine, that's the tangent function. So we have tangent of theta whole squared plus 1 equals to 1 over cosine theta. So that's the secant function. So we have secant of theta whole squared. That means we can we have the new identity tangent squared theta plus 1 equals to secant squared theta. Now what we can do, we can replace secant squared theta with tangent squared theta plus 1. But that means our expression will become 1 plus tangent squared theta in place of secant squared theta, and we have secant squared theta, so it is 1 plus tangent squared theta minus 1. So here 1 and 1 gets cancelled. We have 1 plus tangent squared theta multiplied by tangent squared theta, which gives us tangent squared theta plus tangent theta raised to the power of 4, which is the expression on the right hand side. So we can start from the right hand side and we can obtain the expression on the left hand side, and in that case all we have to do is replace tan squared theta with secant squared theta minus 1. Hence we have successfully shown that the left hand side of a given equation is equals to the right hand side, hence proved.